Hello Year 10 and welcome to my physics lesson on displacement and distance. Before we start the lesson, let's make sure you've got the correct equipment. So you're going to need some paper, pen, pencil, ruler and a calculator. Pause the video now and get your equipment ready. Now that you've got your equipment ready, it's important that you understand that this is a video lesson and you should not rush your way through it. When you see the yellow star, there's going to be work for you to do on that slide, and so you may need to pause the video to complete it. But again, you've got plenty of time. This lesson is designed to last approximately 45 minutes. So to start our lesson today, you need to make sure you put the date and title, and so the title is on the screen in front of you. It's called Distance and Displacement. Pause the video, get your title written. On the screen in front of you is your starter task. I've asked you to identify whether or not the different measurements given to you on the screen are a scalar or a vector measurement, and I've also asked you to write a definition for the two words. Pause the video now. How did you get on? So time is a scalar measurement, length is scalar, temperature is scalar, mass is scalar, and brightness is scalar. They're scalar measurements because all they need is a value in a unit. Whereas weight and velocity are both vectors because not only do they have a value and a unit, they also require a direction. And that's shown by the arrow showing weight and the arrow on your velocity picture there. So if we're going to write down definitions of the two words, a scalar quantity has a size only, whereas a vector quantity, which is really a specialist physics term, we don't use it anywhere else really, and so vectors need to have both a size and a direction. Now that direction can either be given as a compass point, as in the example there, it says 30 kilometers north, or it can simply be represented by an arrow on a diagram to show the direction of motion. So if we're looking at the two words distance and displacement, by the end of today's lesson, I want you to be able to state the difference between them and making sure you know which one's scalar and which one's vector. And then I also want you to be able to work out distance and displacement values from written descriptions. So if we look at the word distance, we use it all the time in physics, but also outside the physics classroom. And so it's important to understand that that's a scalar quantity. So when we're quoting a distance, we're basically saying how far an object is moved. And we measure that in physics in meters, but there's lots of other units that we could use. Centimeters, kilometers, millimeters. It all depends on the size of the distance being measured. When it comes to displacement, displacement is a word that really you're only going to be using in the physics context. And displacement is a vector quantity. Now, as a vector quantity, it has to be given a length and also a direction. But the length is very important. When it's a displacement, it's the straight line distance between your start and finishing points, independent of any route taken to get there. And when it comes to the direction, you need to make sure that it's the direction from the start point, not a direction during the course of the journey. Because these two definitions are really important, I'd now like you to spend between a minute and 90 seconds memorizing the information. So pause the video now. Well, how did you get on? Write down as much as you can remember now under the heading distance and displacement. I'm going to give you about a minute to do that. Okay, grab a pen and adjust your definitions to see how you got on. So distance is your scalar, and it's simply how far something has moved, and it's generally measured in meters. Whereas displacement is that vector quantity, it's how far an object has moved from its starting point. Again, it's usually measured in meters, but must have a direction as well. And remember, it's that straight line distance between your start and finish points. So if we now look at objective number 2, which is work out distances and displacements from written descriptions, let's have a look at this first one. Read the description very carefully. Now, if we're going to work out how far the bear has skied, you need to break down the journey into the 3 components. And so I'm going to add arrows to the diagram to help us to do that. So the bear skis 7 meters to the tree. So there's the arrow showing him skiing to the tree. He then turns round and skis back to his starting point. There's my arrow showing him skiing back to his starting point. He then decides to ski all the way to his house. And so that's my third arrow showing that there's 3 components to this journey. So now that you've got the arrows to help you, pause the video and work out the distance travelled. Did you get the distance right? So 7 meters to the tree, 7 meters back, and then 12 meters down to the house. That gives us a total distance of 26 meters. Now, if I ask the question, what is the displacement for the journey? That's when you've got to think more carefully and make sure you know the definition of displacement. So think about the same journey and what do you think the displacement would be? Pause the video to give yourself time to think. Okay, so now let's really break this down. It does not matter if the bear has skied to the tree and back, because the starting point is where he is now on my diagram, and the ending point is the house. So if we think about the direction first, he's skiing east according to my compass, and the displacement is from the start point to the house. That tree is now unimportant. So the displacement is simply 12 meters east. Now read this journey and see if you can work out the 2 answers on your own. Whilst you've got thinking about it, pause the video. Okay, so this new journey simply says the bear's going to ski from his house to the tree and back again. So if I ask you about the distance, it's the distance to the tree plus the distance back again. So that would be 24 plus 24, because that's 12 plus 12. But the displacement is a unique value. He went from the house to the tree and back to his house again. So in terms of his overall journey, he's not moved because the displacement would be 0. We don't give a direction when it's 0 movement. His start and his finish point is the same place. So there's 0 displacement from that starting point. Okay, time for you to do a bit of work on your own. I've got 4 different journeys there. I'd like you to work out the total distance travelled. To give yourself time to think, pause the video now. Right, so this was just maths. So let's have a look at that first question. A man walks 150 meters north, then 150 meters east. The directions are unimportant. It's the distance that he's traveled. So I just do 150 plus 150 gives me a total distance of 300 meters. So the same applies for question 2. I'm only interested in the distances, not the directions. So I'm just going to add the 2.5 kilometers to the 3.5 kilometers to get a total of 6 kilometers. It is important to take notice of the units in the question so that you don't always write meters when it doesn't apply. Now we've got a plane flying and he's got 3 parts to his journey this time. So we have to add all 3 distances together to give me a total of 2,250 kilometers. And finally, we've got a 3-part journey for the boat as well. Add the 3 together and you should have got a total distance of 330 miles. Again, I've changed the unit in that last question, and it's important that you recognise that. Now, before we move on to thinking about measuring displacements, I need to check that you know your compass directions and how to represent them on a page. So if I put my compass up here, you'll notice north is pointing up the page on the compass needle there, east is pointing to the right, south is pointing down the page, and west is pointing to the left. And so that's what we use in exam questions. North is up the page, east is to the right, south is down, and then west is to the left. Now, you're also going to need to know the in-between directions. So look at my northeast pointer on the compass there. That's pointing up and to the right. My southeast is down and to the right. My southwest is down and to the left. And then finally, my northwest is up and to the left. And so you need to be able to visualize that on an exam paper. It might be worth, if they ask you to do a displacement, just to draw yourself a little compass if it helps. So, how do we work out a displacement from a description? The only way to do this is to actually sketch it out, to draw the route out in a scale diagram. So I'm going to help you do this one. So all I want you to do is listen and watch. I don't want you to do anything on your paper. So my description says a bird flies 10 meters north, which is going to be up the page. It then flies 10 meters east, which we're going to draw as right across the page, and then 10 meters south. Now, if we're going to draw a scale diagram, you're going to need a ruler with measurements on it. And so in this case, I'm going to suggest that 1 centimetre on your ruler is equivalent to 1 metre on our journey. So let's see how I draw it. So I've drawn my little start point, making sure I've got space around it to draw my route. So I'm going to draw a 10 centimetre line up the page because that represents 10 metres. I'm then going to draw a 10 centimetre line across the page in right to represent my 10 metres east. And then I'm going to draw a line 10 centimetres down the page to represent my 10 metres south. And notice I put the arrows in the direction that the journey is described. And I'm now going to put my finish point. So that's my journey. And so my first question asks, what is the distance travelled? Now, distance is just how far my journey took. So I took 10 metres north, 10 metres east, 10 metres south. So all I've got to do is add those three together to give me 30 metres in total. So that's quite straightforward. And we don't really need to have drawn the diagram for that. But we need the diagram to work out the displacement. Because if we remember, a displacement is the single straight line drawn between my start and finish points. So I'm going to add that to my diagram now. So you can see that's going straight across the page in an eastwardly direction. But how long is that line? Well, if we look at it, we've actually drawn a square. It's 10 by 10 by 10 by 10. So my displacement is going to be 10 meters from start to finish point in the easterly direction. So that's 10 meters east. Now we're going to have another go together, but this time you're going to draw it with me. So get yourself a pencil and your ruler ready and make sure that you've got a nice space on your page to draw this route out. So let's read the route first so we can think about it. The car's going to move 100 meters east, and so that's right on our page. It's then going to move 70 meters north, and so we're going to go up. And then it's going to move 80 meters west, and so that's left on my page. Now we also need to decide on a scale. Now, because we've got 100 meters there, it would be a good idea to use 1 centimeter equivalent to 10 meters. So let's have a go at drawing our route. So first of all, we put our start point. We then put our ruler on our page and we draw our line right across the page to represent that 100 meters. So your line needs to be 10 centimeters long. We've now got to add to that our 70 meters north. And so that's going to be a 7 centimeter line up your page. And finally, our 80 meters to the west needs to be an 8 centimeter line to the left on your page. Mark your finish point and your final measurement there. We've not drawn a square, so then calculating that displacement is going to be a little bit more tricky, but it's very, very doable. So let's do the total distance travelled first. Really, we just need to look at the question and add the 100, the 70 and the 80 meters together. Or we can use the units on our diagram and scale it up. Either way, they both come out to 250 meters. But what about that displacement? So remember, the displacement is that straight line from the start to finish point. So I've drawn it on the diagram. Now, what you've got to do now is measure that line with your ruler. I need to know how long that line is in centimeters. And when I drew this out, I got a line that was 7.3 centimeters long. But remember, that's not the displacement length because this is a scale diagram. So I need to multiply that by 10 to give me 73 meters. But I've still not given a displacement because the displacement needs a direction. So at the end of my journey, I've gone up from my start point, which is north, but I've also moved a little bit right of my start point, which is east. So my direction is northeast. So my overall displacement answer should be 73 meters northeast. Now it's your turn to have a go on your own. So do exactly what I just did in the example. And if you need help, remember you can rewind the video to show you what to do. I've told you to use 1 centimeter equals 10 meters again. So pause the video now. So how did you get on? So my little start points just appeared on the screen there. I'm going to draw a 5 centimeter line up for my north direction. I'm going to do a 5 centimeter easterly, so that's right. And then I'm going to draw a 7 centimeter line south down my page. If I add all of those together, I get 12 centimeters on my scale diagram, but I need to multiply that by 10 to give me 120 meters as my total distance. In terms of my displacement, I draw on my displacement line, I measure it with my ruler, and when I measured it, it turns out to be 5.5 centimeters. I need to multiply that by 10 to get the overall length, so that's 55 meters. And now I've got to decide the direction. Now in this example, my finish point is down the page from my start point and to the right, so that's southeast. If you haven't managed to do this for yourself, I'd like you to draw this one out, so you might need to pause the video to allow you to do that. Okay, that was two quite tricky journeys there. Now, they generally only ask you to draw vector triangles for routes and to estimate the displacement direction. So I've given you 2 routes on this slide, and in each case, what I'd like you to do is draw your vector triangle. Now, to do that, you draw your 2 parts of the journey that they've given you, and then you fill in the displacement arrow from your start and finish point, and that should end up as a triangle. But try and do it to scale. Pause the video now. Right, so let's go through the answers. So my first one, a plane is flying 250 kilometers north and then 1,000 kilometers east. So I need to draw a line up on my page. I need to draw a line to the right of my page, and that line there needs to be 4 times longer than the original, because it was 250 kilometers and then 1,000 kilometers. But because they haven't asked you to measure the displacement, a rough estimate is good enough. Now I put on my measurements and finally my displacement arrow. And remember, it's got to go from the start to the finish point. And direction-wise, that's up and to the right, and so that's northeast. In the second example, my car's driving 70 miles to the west, so we need to draw a line to the left on the page. It then drives 20 miles south, so I need to draw it down, and again try and estimate the length there. It doesn't have to be perfect, but it needs to look right. Put on my displacement arrow and my measurements, because that's now my vector triangle, and my displacement direction in this case is southwest. Right, we've done an awful lot today, and I think we've matched all of our objectives. So last but not least, let's see if you can remember the definitions of those three really important things there. What is a vector? What is displacement? What is distance? Pause the video and write your answers. How did you do? So if I ask for a vector, the critical thing there is to tell me it's a measurement with a size and direction. If I ask you what's the displacement, that's that straight line distance between 2 points, but you must quote there that it's got a direction because it is a vector. However, when I ask you what is distance, that's just how far an object has moved in total. Well, that's the end of today's lesson on distance and displacement. Make sure that you have signed off in terms of finishing the video. Bye for now.